All right. Where were we? We were talking about this function, right? And we found that it's defined everywhere except for when x is equal to -1. Okay, so in interval notation, this is what it looks like. So the smallest thing you can get is -infinity. And then that goes all the way up to -1. We combine that with the second piece, -1, to positive infinity. And that is one way to write our answer in interval notation. You could also use set builder notation. There are some cat hairs on here. Say it's a set of all x such that, always what you do, and then just plug in your inequality. X is not equal to -1. So I think set builder notation is actually a little nicer here than interval notation, but you can use either. I'm never going to force you to use one way or the other. Okay, also my camera's a little zoomed out now compared to what it was before, but don't worry about that. All right. And that's most of it. Part C is really where we see the last thing that's going to happen. And then we're going to do a couple more examples just to really dig deep. Okay, but if you want to get to the the homework after C, go ahead. H of x is equal to the square root of x plus 2. Again, we are dealing with real valued functions. So we have to ask ourselves, okay, what values are going to make this not real? We can't divide by 0. And if we want things to be real and not complex, we need to take the square root of a non-negative number, okay? So inside of the square root needs to be greater than or equal to 0 here for our domain. So we just say, what is the inside of the square root? Why? It's x plus 2. That has to be greater than or equal to 0. We basically have our domain right here, right? Subtract 2 from both sides. X is greater than or equal to -2, and that's our answer. So again, everything to the right of -2 is okay. So when we write interval notation, smallest thing it can be is -2. The biggest thing it can be is infinity. We got that equal sign, so a bracket on the -2. Infinity is always a parenthesis. Or the set of all x such that, for set builder notation, always starts this way. Plug in that inequality x greater than or equal to -2. These are both good answers to part C. All right, and that's most of it. Do a couple more problems if you want, or you can just move on to the homework right now. F of x equals the absolute value of x. We can take the absolute value of a positive number. That's fine. Absolute value of a positive number is just itself. The absolute value of 0 is 0, and the absolute value of a negative number is a positive number. So we can take the absolute value of anything we want. So we say the domain is all real numbers, or -infinity to infinity. Okay. That's it. All right, part C, we're going to make things a little bit more exciting. G of x equals 2 plus x over the square root of 2 minus x. October, can you please stop jumping up and down on top of my... It's upside down, but she's just having a good old time with my notes. Oh my goodness. Sorry. I get a little distracted sometimes. That's what happens when you work from home. So we have two things, right? We have a denominator and we have a square root. So we need two things, right? Denom cannot be 0, and the inside of the square root has to be greater than or equal to, has to be positive or 0. So this time we have two things going on. So we just approach these individually and then try to combine them. So the denominator can't be equal to 0. So square root of 2 minus x cannot be 0. You can square both sides. This is when 2 minus x is not equal to 0. Add x to both sides. That's when x is not equal to 2. So x can't be 2. But we have more conditions as well. Subtract 2 from both sides. Divide by a -1. Remember, when you divide by a -1 or multiply by a negative number, the inequality flips. So x can't be 2, and x has to be less than or equal to 2. How do we combine these things? X can be anything except for 2, and x has to be 2 or less. So we combine these and say, okay, well then just x can't be 2, but it can be anything less than 2. Okay, so that's how we sort of combine these. And then we use this right here for our answer. Negative infinity to positive 2 with brackets, or the set of all x such that x is less than 2. Like so. All right. That's the first video. Part 1, or part A and B. All right. Get started on those homework problems and then watch the second video when you've gotten to that point.